Today, we're uncovering the journey behind one of the most versatile plant extracts in modern health and beauty, aloe vera gel. Revered for centuries in various cultures as a soothing, moisturizing remedy, aloe vera has risen to global prominence for its healing properties and wide range of applications, from skincare and cosmetics to dietary supplements. But how do massive factories transform the thick, gooey sap of aloe vera leaves into the bottled or packaged gel you see on store shelves? In this video, we'll travel from sprawling aloe vera farms to state-of-the-art processing plants, delving into every step, from leaf harvesting and sap extraction to stabilization, purification, and packaging. By the end, you'll understand how cutting-edge technology and meticulous handling preserve aloe vera's natural goodness on a massive industrial scale. Aloe vera has been used in traditional remedies for thousands of years. Its cooling, hydrating properties and purported healing benefits make it a staple in countless consumer products, such as lotions, gels, drinks, and even dietary capsules. With rising wellness trends, global demand for aloe vera extracts continues to soar. Modern factories now process thousands of leaves daily, producing massive volumes of gel for the beauty, pharmaceutical, and food industries. Consider a major cosmetics brand launching a new aloe-infused moisturizer. Behind the scenes, that single product line might require tons of aloe leaves every month. Factories coordinate with multiple farms to ensure there's a steady supply, while researchers test the gel's consistency. Some farms even schedule harvesting in waves, so each factory can receive a continuous flow of fresh aloe leaves throughout the year. Though many species of aloe exist, Aloe barbadensis Miller, often called aloe vera, is the most commonly cultivated for commercial gel. Farms are typically located in regions with warm, arid climates and well-drained soil, like parts of the Americas, Africa, and Asia. The plants require minimal water, making them relatively drought-tolerant. Farmers carefully select varieties with optimal leaf size, gel content, and minimal bitterness. By crossbreeding and research, some aloe strains yield more consistent gel with favorable properties, like lower aloin, a bitter component, and higher polysaccharide content believed to have health benefits. On a large-scale farm in Texas, for instance, agronomists might grow test plots of different aloe strains side by side. They measure leaf thickness, overall gel yield, and even the taste profile to see which variety will thrive best under local conditions. Data from these test plots helps them decide which strain to cultivate across hundreds of acres. Aloe vera fields can stretch for acres, rows upon rows of spiky, thick leaves radiating from the base. Plants usually take 1 to 2 years to mature enough for harvest. Workers or mechanized harvesters carefully cut the outer, older leaves at the plant's base, leaving younger, inner leaves to continue growing. Timely harvesting ensures leaves haven't dried out or become too fibrous. Typically, the harvested leaves are quickly transported, sometimes within hours, to processing facilities to preserve freshness and active compounds. Picture a harvesting crew at dawn. They walk through the rows of aloe plants, selecting leaves with just the right thickness and color. They stack them into clean crates that keep air circulating around each leaf, reducing the chance of mold or bruising during transport. These crates are then loaded onto a truck headed directly to a nearby factory. Factory-bound leaves travel by truck or trailer, often stacked or placed in bins for airflow. On arrival, each batch undergoes inspection. Technicians look for signs of mold, physical damage, or discoloration. Leaves that don't meet quality standards are discarded or reserved for non-food grade uses, like compost or certain industrial applications. Since aloe's beneficial compounds degrade over time, rapid processing is vital. Some operations keep leaves under shaded or cooled conditions until processing begins, slowing any breakdown. In a large facility, staff might unload each truck and use handheld scanners to record leaf weight and time of arrival. If certain leaves show bruising or yellowish patches, they're set aside for non-food uses, such as making eco-friendly cleaning solutions. This level of tracking ensures the highest quality leaves go into gel products meant for human consumption. In the factory's intake area, leaves are washed with pressurized water or mild food-safe detergents to remove dirt, debris, and potential contaminants. Rumor has it, some aloe leaves are so pampered in these washes that they think they're at an all-expenses-paid spa. The only thing missing is cucumber slices for their eyes. Oh wait, employees wearing gloves, aprons, and hairnets stand along conveyors, trimming away thorns or browned leaf tips. Next, the leaf base, where it was cut from the plant, may be trimmed to remove hardened parts. Any leftover sap or yellowish latex draining from the leaf's edges can be rinsed off, minimizing bitterness and ensuring a cleaner gel extraction. Some factories install high-powered rotating brushes to scrub the leaves gently but thoroughly. Others might use a mild chlorine-based sanitizing solution, followed by a rinse with purified water. You might see operators holding each leaf under a guided spray nozzle, making sure that all spines along the edges are removed without cutting away too much of the valuable gel inside. The heart of aloe vera processing lies in gel extraction. Skilled workers or specialized machines fillet each leaf. They slice away the green outer rind, both top and bottom, exposing the translucent gel inside. This gel is the prized interior, teeming with polysaccharides, enzymes, vitamins, and more. Large factories often automate this step with advanced filleting machines that carefully peel away the rind. Minimal rind residue ensures fewer unwanted compounds and less contamination. The extracted gel pieces, or fillets, move on for refinement, while the discarded rind heads to compost or alternative uses. In smaller scale operations, workers might use a sharp knife to delicately remove the rind, leaving a thick slab of clear gel. In high-tech facilities, conveyor belts guide the leaves through blade mechanisms set to precise angles, reducing the chance of human error and ensuring every leaf is processed uniformly. Any leftover rind is often collected in large bins, later composted to enrich farm soil. Even after filleting, trace amounts of aloe latex, the yellowish fluid near the rind, might remain. Latex contains aloin, which can cause bitterness or laxative effects if consumed in high amounts. Factories typically rinse the gel fillets in cool, food-grade solutions or purified water to remove any remaining latex or debris. This thorough rinse step is critical. The cleaner the gel, the purer the final product's taste, color, and odor. Some manufacturers test aloin levels at this stage to ensure compliance with regulatory limits, especially for edible products. You might see workers immersing the gel fillets in large stainless steel vats filled with purified water. Sometimes, gentle stirring equipment is used to help dislodge any remaining latex. In other cases, special filters capture tiny particles that break off during filleting. A quick test with chemical strips or a spectrophotometer can confirm whether the aloin level is below the desired threshold. Once the raw gel is free of rind and latex, it's often crushed or ground into a pulp. Large stainless steel grinders or pulpers break down the fillets, creating a consistent gel slurry. Alternatively, some lines juice the gel, pressing it to release a fluid extract. Operators must handle this process gently to avoid excessive aeration or oxidation, which can degrade beneficial compounds. Some factories use closed systems where oxygen exposure is minimized, helping preserve aloe's natural enzymes and nutrients. In one facility, a technician may monitor the pulping process from a control panel that shows temperature, pressure, and oxygen levels in real time. If foam starts forming, they might reduce the rotational speed or add a slight vacuum to remove air bubbles. This delicate balance ensures the final gel remains rich in vitamins and enzymes, providing maximum benefit to consumers. Aloe gel can foam during pulping. Defoaming agents, mechanical paddles, or vacuum systems remove excess froth. Factories may also filter or centrifuge the gel to remove any remaining pulp bits, achieving a smoother consistency. This clarity level depends on product specifications. Certain brands want a crystal clear juice, while others prefer a more natural pulpy texture. Throughout these steps, temperature and pH control are key. Keeping temperatures moderate helps prevent heat damage, while pH buffers can stabilize the gel's acidic or neutral profile for better shelf life. For a brand marketing an organic aloe juice, the manufacturer might skip certain defoaming agents and simply rely on gentle centrifugation. Meanwhile, a skincare brand looking for a smoother lotion base might pass the gel through multiple filters until there's no visible fiber. Technicians in a quality lab might measure pH every few hours, adjusting it by adding tiny amounts of natural acids or bases to keep the gel stable. To ensure microbiological safety and extend shelf life, aloe gel undergoes preservation. Two common approaches are pasteurization and cold processing with preservatives. Mild pasteurization, heating the gel to a controlled temperature, often around 70 to 80 degrees Celsius, or 158 to 176 degrees Fahrenheit, for a brief time, then rapidly cooling. This kills bacteria and enzymes that could spoil the product. However, excessive heat might degrade some active components. Cold processing and preservatives, relying on natural or food-safe antimicrobial agents, plus filtration and low-temperature storage to maintain freshness. This approach may preserve more nutrients but can be costlier and requires strict sanitary controls. Either way, factories calibrate these steps to balance safety, flavor, and bioactive retention, customizing methods for different product lines, whether a skincare gel or a consumable juice. A juice company might opt for mild pasteurization to extend the product's fridge life for a few months. They'll use large stainless steel pasteurizers with digital timers that bring the juice up to the exact temperature required. In contrast, a premium cosmetic brand might employ cold processing, adding natural preservatives like rosemary extract or citric acid to keep the gel stable without heat. Technicians double-check microbial counts in a sterile lab area, ensuring no harmful bacteria remain. Depending on the final product's purpose, factories may blend aloe gel with other ingredients like citric acid for acidity control, natural flavors, thickeners for lotions, or sweeteners for beverages. Some brands add vitamins, herbal extracts, or essential oils to create specialized product lines, e.g. aloe juices with fruit flavors or aloe-based skin lotions. R&D teams work to optimize taste, texture, fragrance, and shelf stability. Each batch is tested for consistency, ensuring that customers get a uniform experience from bottle to bottle. Imagine a beverage company formulating a new aloe drink with apple or pineapple flavors. They might run multiple pilot batches in a small lab kitchen, testing different sweetener levels to ensure the flavor remains refreshing without masking aloe's natural taste. Meanwhile, a skincare brand might mix aloe gel with chamomile extract and a mild thickener to create a soothing facial mask. Lab technicians continuously tweak the recipe, checking viscosity, scent, and skin feel before finalizing the formula for mass production. Strict quality control measures underpin aloe vera processing. Lab technicians analyze samples for purity and color, checking for discoloration or excessive pulp, moisture content, and viscosity, confirming texture aligns with brand standards, aloin and anthraquinones, ensuring safety for ingestible products, microbial load, testing for bacteria, yeast, mold, or pathogens. Some producers also verify the gel's polysaccharide content, as these are believed to be major contributors to aloe's health benefits. Certificates of analysis, COAs, may be provided, especially for export or premium lines. In a dedicated quality lab, you might see technicians in sterile coats and gloves placing small gel samples into high-precision instruments. A spectrophotometer could measure the gel's color and translucency, while advanced testing equipment checks microbial levels. If a batch fails to meet certain thresholds, say it has too high a microbial count, it's either reprocessed if possible or discarded to protect consumer safety. Some premium brands post these lab results online for full transparency, reassuring customers about the product's integrity. After passing final inspections, the aloe vera gel proceeds to packaging lines. The format varies: bottles or jars for consumer gel or juice products, tubes for skincare lotions, creams, or gels, bulk drums or totes for cosmetic or food manufacturers who'll use aloe as an ingredient. Automated fillers portion gel into containers at high speed, sealing each with tamper-evident caps or seals. Labels list ingredients, usage instructions, nutritional data if applicable, and brand info. Some lines use nitrogen flushing to reduce oxygen, extending shelf life. In a large bottling plant, conveyor belts carry empty bottles under filling nozzles, dispensing precise amounts of aloe gel. A sensor ensures each bottle is filled consistently, reducing spillage or shortages. Sealed bottles move through a labeling station, where product information, barcodes, and batch numbers are applied. Finally, a quick visual check by the packaging team verifies that each bottle is properly sealed and labeled before being boxed for shipping. Once packaged, boxes or pallets of aloe vera products move to climate-controlled warehouses, awaiting distribution. Stable temperatures, often around 15 to 25 degrees Celsius or 59 to 77 degrees Fahrenheit, help maintain gel quality. Prolonged exposure to heat or sunlight can darken aloe gel or reduce efficacy. Logistics networks ship products worldwide. Supermarkets, pharmacies, online retailers, and bulk buyers. Proper handling during transit prevents freeze-thaw cycles that could alter texture or degrade nutrients. Think of a bustling distribution center where forklifts load pallets of aloe-based skincare products into temperature-controlled trucks. Each pallet might be wrapped in plastic film to prevent dust or moisture damage. Tracking systems update in real time, so the factory knows exactly when a shipment reaches the retailer. This ensures products remain in optimal conditions from the moment they leave the warehouse until they appear on store shelves. Aloe vera-based drinks, soaps, shampoos, and cosmetics flood the market. Factories tailor formulations to meet branding objectives, ranging from organic or cold-pressed claims to functional beverages boasting immunity or digestion benefits. Clear labeling and certification, like USDA, Organic, ECO, CERT, or GMP, reassure consumers about product authenticity. Some top-tier brands emphasize no added colorants or synthetic fragrances, appealing to consumers seeking natural solutions. Consider a startup company developing a premium farm-to-bottle aloe juice. They may highlight their direct relationship with local farmers, the purity of their cold press technique, and the eco-friendly packaging used. Meanwhile, a large multinational skincare brand might develop a line of aloe shampoos geared toward reducing scalp irritation. They might partner with dermatologists who test the product's claims, then showcase those findings on the label to attract health-conscious customers. As aloe vera production expands, sustainability matters. Farms employing water-efficient irrigation, like drip systems, conserve resources in arid regions. Land stewardship ensures soil health and habitat protection. Factories adopting green energy sources or recycling wastewater reduce their ecological footprint. Responsible waste management includes composting trimmed rinds or reusing them in other products. Companies that can market eco-friendly and ethically sourced aloe often win over discerning consumers who value both quality and environmental responsibility. In an eco-conscious operation, you might see solar panels on warehouse roofs powering conveyor belts and lighting systems. All the discarded leaf rinds could be composted into nutrient-rich material fed back into the aloe fields, creating a closed-loop system. Some companies also donate a portion of their profits to local reforestation projects, further enhancing their environmental and social impact. Research continues to refine and enhance aloe's processing. Scientists experiment with minimal heat treatments or advanced cold press methods to preserve the maximum level of bioactive compounds. Novel filtration or membrane technologies may extract beneficial components while discarding bitter elements. AI-driven sensors in the factory might monitor pH, temperature, and flow rates in real time, tweaking processes to yield consistent quality. Meanwhile, lab-grown or genetically optimized aloe could yield higher gel volumes or more stable polysaccharides. Picture a high-tech research lab where scientists are testing prototype membrane filters capable of isolating specific enzymes in aloe. In another corner, technicians run AI simulations that predict the optimal pasteurization temperature based on incoming data about leaf size, gel density, and even the local climate. These breakthroughs might not be mainstream yet, but they pave the way for higher quality aloe products with a smaller ecological footprint. With rising interest in transparency, some aloe factories implement blockchain or sophisticated traceability systems. QR codes on packaging can show farm origins, harvest dates, and lab test results. Trust in authenticity matters in an industry sometimes plagued by adulterated or watered-down aloe products. Reputable brands emphasize rigorous standards from farm to final bottle, cementing consumer trust and loyalty. Imagine scanning a QR code on your aloe juice bottle. Instantly, you see which farm the leaves were harvested from, the date they arrived at the processing plant, and even a short video of the quality inspection process. This level of transparency reassures buyers that they're getting pure aloe, increasing brand loyalty in a crowded market. Regulatory bodies worldwide set guidelines for aloe vera gel purity and safety. For example, the International Aloe Science Council IASC offers certification verifying authenticity and content. Cosmetics might fall under local FDA regulations, while ingestible aloe must meet food safety standards. Producers keep pace with these rules, performing regular audits and adopting standardized labeling to ensure compliance across different markets. A brand selling in multiple countries might navigate a maze of regulations, ranging from FDA guidelines in the United States to EFSA, European Food Safety Authority, in the European Union, and local health ministries across Asia. They might hire compliance specialists to ensure each formula, label, and marketing claim meets the necessary standards. Achieving certifications like IASC can boost credibility, often displayed prominently on product packaging. As consumers continue embracing natural health remedies, aloe vera's popularity looks poised to grow. Factories will adapt by scaling up, refining processes, and diversifying product lines. Innovations may yield more potent extracts or specialized compounds for targeted skincare or medical applications. Automation and eco-friendly practices will help maintain supply while respecting the environment and local communities. In the end, aloe vera's success hinges on balancing modern factory efficiency with nature's delicate gifts, capturing the best of both worlds in every bottle or tube. A future scenario might involve drone-assisted farming, where drones assess plant health and water needs. On the factory floor, robotic arms could handle filleting at incredible precision, minimizing waste. Meanwhile, researchers might isolate specific aloe compounds proven effective for wound healing, eventually leading to a new generation of medical-grade aloe patches. This marriage of technology and tradition ensures that aloe vera continues to thrive as a go-to plant for well-being. We've tracked aloe vera gel from leaf to final product, witnessing a blend of careful farming, advanced machinery, and quality-driven protocols that preserve the plant's treasured properties. Whether you're using aloe gel to soothe a sunburn, hydrate your skin, or enjoy a refreshing beverage, each squirt or sip connects you to an intricate chain of farming, science, and technology. If this deep dive intrigued you, consider subscribing for more explorations into how everyday items are produced. Share your thoughts in the comments, and next time you reach for an aloe vera product, you'll know the remarkable journey each drop has taken, from spiky leaf on a sunlit farm to a polished container in your home.